Good afternoon, everyone. I'm Psycho Aryan. We're here to discuss the measure of spread in statistics with my co-members.
I am Julia del Villarreal. I am Melvin Asoy.
I am Carla Jane Norbula.
I am Jean Pantoliano.
I am Marjorie Masana.
And we will start our measure of spread discussion. So, when you ask, what is measure of spread? Measure of spread, also known as measure of dispersion, provides insights in how spread out of varied data set is. They help to understand distribution of data points around the central value. This includes range, interquartile, variance, and standard deviation. First, you will ask, what is range? Range is the data of set, and it is the difference between the largest and the smallest value of the data. So, how to solve a range? First, I will give an example. One, 3, 4, 6, 8, 9, and 10. So first you will get the median point. So the median in this data set is 8. So this is our median. And our maximum data is 10. And our minimum data is 1. Then remember that the range formula is maximum minus minimum data. So range equals maximum minus minimum. So our maximum here is 10. And then our minimum is 1. So our range here is 9. Now you know how to solve the range. Then second one, we'll go to interquartile range and how to solve an interquartile range. I will give you an example on how to solve interquartile range. So the data is 4, 9, 13, 19, 22, 29, 44, 56, and 75. Then you will get the median first. So our median here is 22 because mao man siya center sa tanang data, mana siya ang median. And then you will get the quartiles, first quartile and the third quartile. So remember our formula of interquartile range equals the Q3 or the upper quartile or quartile 3 minus quartile 1 or the lower quartile. So how to know the quartile 1 or the lower quartile? So the middle of 4 to 19 is 11. So the median of 4 to 19 is 11. And how to get the 11? Because 13 plus 9 is 22 and divided it by 2, that's why 11. That is our median. And the next is the upper quartile, 29 to 75. Between it is the median. So the median in this one is 50. So 56 plus 44 is 110. 100. Then divide by 2. That's why our median is 50. So now now we know that our quartile 1 is 11 and our quartile 3 is 50. We can answer the interquartile range. So the quartile 3 is 50 minus 11. Then our answer for interquartile is 39. Next is we will know how to solve the variance. So I will give you another example in how to solve a variance. The data I will give is 17, 15, 23, 7, 9, 13, and now, and how to get the variance first, you need to get the mean. So to solve the mean, you need to add all the data and then divide by the sample number. So the sum of all the data is 84. And you will divide it by the how many numbers in a data. So 1, 2, 3, 4, 5, 6. Divide 6. So our mean here, this symbol stands for mean. So our mean here is 14. So we will subtract each of the data to the mean. So 17 minus 14 is 17 minus 14 is 3. And then 15 minus 14 is 1. And then 23 minus 14 is 9. And then 7 minus 14 is negative 7. And then 9 minus 14 is negative 5. And 13 minus 14 is negative 1. And the next step is to square all the data answers. So 3 to the power of 2 is 9, and 1 to the power of 2 is 8. 1 and 9 to the power of 2 is 81, and negative 7 to the power of 2 is 49, and negative 5 to the power of 2 is 25, and negative 1 to the power of 2 is 1. And the next step is to add all these answers. Nine plus 1 plus 81 plus 49 plus 25 plus 1 is 166. So, and the next step is to divide the numbers of the samples. But remember, the formula of a variance is S squared equals the sum of term in data set minus the mean, n squared, that over n minus 1. So now nga na kay bawal man ta sa atong answer aning babaw sa sum of katong sa term sa data o sa mean nga minus mo ni siya ang answer 166. And then 166. Then kaning n is the number of all the data. So ang number ani kay 1, 2, 3, 4, 5, 6. So 6 then minus 1 equals 166 minus 5. So mo na yung mukhang isolve. 166 divided by 5 equals, our variance here is 33.2. So now we know how to solve the variance. We will now go to the standard deviation. So we will just continue the example because we know the variance. So a variance is the continuous steps of the standard deviation is the continuous steps of the variance. So the next of it is you will just square the square root of the answer. So s squared equals 33.2, then square root s equals 5.76, and this is our standard deviation. In real-life situation, measure of spread are crucial for understanding variability. And now, my other co-members will give an example of a real-life situation about the measure of spread, the range, interquartile, and variance. Lastly, is the standard deviation.
And right now, I'll give you our real-life examples where the range is involved. For example, find the range of a given observation in a set of grade of students 75, 82, 90, 95, and 98. Since the 75 is the lowest value and 98 is the highest value, therefore, the range of the observation will be 98 minus 75 plus 20. Hence, the 23 is the required answer, which is the range of the given observation. And the next real-life example of measure of variability in measure of spread will be discussed by Melody.
So here is the interquartile range about a real-life situation. Basketball points. Example. First, makita ko na ito ang median. Ang median ay katunga sa kanilang mga aning last point o last point. So kaniya ang atong median 5.5. Next, makita ko na po na ito ang quartile 1. Ang quartile 1, tunga na po sa 5 o 1. So, ano yung itong quartile 1, 3. Next is quartile 3. Ang quartile 3, itong ano po sa 6 o 8. So, ano yung 7? Ano yung quartile 3? Remember, our interquartile formula our quartile 3 is 7. So 7 minus quartile 1, 3. So our interquartile range is 4. So mao ni ang ito ang IQR sa basketball points in real life situation. The next real life example of measure of variability in measure of spread will be discussed by Karine.
Our next real-life situation example is about variance. So our example is there are teams of volleyball and we have to find the variance of their wins. So the wins is 2, 5, 8, squared is equals 9. And we have to add this all data set. This is equals 36. Remember, to solve the variance, here is the formula. S squared squared. So our answer here is 36. So we have to put it here 36. And n minus 1. Our here is how many data sets we have. So there are 5 data sets. So 36 divide 5 minus 1 is equals 36 is 4. So our variance is 9. The next real-life equation example of measure of variability and measure of spread will be discussed by Jean Pantoliano.
So our next example is the standard deviation. Our example here is a class of students took a math test. Their teacher wants to know whether most students are performing at the same level or if there is a high standard deviation. So the scores of the test were the score of the test were 85, 86, 100, 76, 81, 93, 84, and 99. So, first step will compute the sample mean. So add all the data set for us to be able to get the mean. So 85 plus 86 plus 100 plus 76 plus 81 plus 93 plus 84 plus 99 is equals to 704. And divide it by the number of scores. So the number of scores were 1, 2, 3, 4, 5, 6, 7, 8. So 704 divided by 8 is 88. So our mean is 88. Next step is subtract the mean from each value. So 85 minus 88 is equals to 3. 86, no, negative 3 rather. 86 minus 88 is equals to negative 2. 100 minus 88 is equals to 12. 76 minus 88 is equals to negative 12. 81 minus 88 is equals to negative 7. 93 minus 88 is equals to 5. 84 minus 88 is equals to negative 4. 99 minus 88 is equals to 11. Next step is square each deviation. So 3 squared is equals to 9. 2 squared, negative 2 squared is equals to 4. 12 squared is equals to 144. Negative 12 squared is equals to 144. 7 squared is equals to 49. 5 squared is equals to 25. 4 squared, negative 4 squared is equals to 16. And 11 squared is equals to 121. Next step is add a deviation to get the sum of squares. So 9 plus 4 plus 44, 144 plus 144 plus 49 plus 25 plus 16 plus 121 is equals to 512. Remember that our formula for variance is s squared equals sum of term in data set minus sample mean squared over n minus 1. So s squared is equals 512 over n minus 1. S squared is equals 512 over n, number of our data, 8 minus 1 is equals to s squared minus, s squared equals 512 divided by 7. S squared is equals to 73.14. Take the square root of the variance to get the standard deviation. So, S equals square root of 73.14 is equals 8.55. So, 8.55 will be our standard deviation. The next real-life example in measures of spread will be discussed by Marjorie Lusani.
So in real-life situations, measures of spread are crucial for understanding variability. For example, consider a company analyzing the salaries of its employees. If the salaries have large spread of high standard deviation, it indicates significant variability in wages among employees. On the other hand, if the salaries have a small spread or low standard deviation, it suggests more uniformity in pay across the workforce.
In conclusion, we all know that a standard deviation by the discuss of our co-members, Jean Pantiliano, and always remember that the smaller the standard deviation, the less spread out of the data set. Or the standard deviation is larger, the more the data spread and the more the data spread out. And if you ask, can standard deviation can be a negative number? The answer is no. And can it be a 0? The answer is yes. And that's all. Thank you.